I'm back.
All right. Okay, it's September 14th, 2025. This is the Cosmology Discussion Group meeting. And welcome everybody. Vladimir is giving us a presentation today. I appreciate that Vladimir is going to present. I want to remind other people that you're all invited to give presentations to try to keep our discussions going. Okay, Vladimir, if you'd like to start, you're welcome to go.
So I would like to share, send a request. Can you see it?
I see it.
Yeah.
Can I start?
Yeah.
Sure, go ahead. I see it.
Okay, the title of my presentation today, Establishing Physical Parameters Within the Framework of World-Universe Cosmology. Abstract. Hypersphere World-Universe Cosmology offers a new perspective on the observable world and the discipline of cosmology. Rooted in classical physics, WC challenges fundamental assumptions in both cosmology and physics. Rather than claiming to account for all available data or provide a fully finalized theory, WC establishes a foundation for the new cosmology anticipated by Paul Dirac in 1937. While further refinement by the global physics community is essential, WC principles, together with groundbreaking discoveries from the James Webb Space Telescope and Dirac's enduring vision, highlight the urgent need for transformative shift in astronomy, cosmology, and classical physics. Introduction. Classical physics before quantum physics. The concept of ether was first introduced by Newton in 1675. Following the work of Jung and Fresnel, light was understood as a transverse wave propagating through an elastic medium called luminiferous ether. Since elastic matter of an ordinary type can only transmit longitudinal waves, the unique properties of ether attracted attention. In 1846, John McCulloch proposed a theory of rotational elastic medium in which the energy of deformation depends only on the rotation of volume elements, not on their compression or distortion. His formulation produced equations analogous to Maxwell equations, showing that such a medium could transmit transverse waves. However, the concept of luminiferous ether was abandoned with the advent of special relativity in 1905. Lagrange's theory of gravitation, first suggested by Fatio in 1690 and later by Lissajous 1748, offered a kinetic explanation of Newtonian gravity. The theory proposed that streams of unseen particles, ultramundane corpuscles, impinge on matter from all directions, with bodies partially shielding one another and thereby creating a net attractive force. This was the first theory to describe gravity as an emergent phenomenon. The kinetic theory of gases explained macroscopic properties, pressure, temperature, viscosity, thermal conductivity through the motion of molecules. In 1859, Maxwell derived the Maxwell velocity distribution, the first statistical law in physics showing that the macroscopic behavior of gases emerges from microscopic motion. Maxwell equations, 1861, unified electricity and magnetism. By comparing the electrodynamic constant C, measured by Weber and Kohlrausch in 1857, with Fizeau 1849 measurement of light velocity, Maxwell identified light as an electromagnetic phenomenon. It is very important to stress that he thought it might be electromagnetic phenomenon. That's it. There is no speed of light. The Rydberg constant, R infinity, first introduced in 1888 as a fitting parameter for hydrogen spectra, remains one of the most precisely determined physical constants. The electron charge to mass ratio, denoted here as RT after Thomson, was first determined by Thomson in 1897, a milestone since the electron's mass could not be directly measured. The Planck constant H, derived in 1901 from black body radiation studies, was based on statistical thermodynamics prior to the establishment of quantum mechanics. Using Boltzmann entropy formula, S equals KB, whereas KB Boltzmann constant, ln W, Planck introduced H as a factor that converts units of frequency nu into units of energy E. He calculated the value of H that is within 1.2% of the currently accepted value. Let me stress one more time. There is no quantum mechanics, there is no quantum physics, there is no H introduced by somebody else. All these parameters was introduced before quantum physics. The last one, H Planck constant, was in 1901. Fundamental physical constants. Based on experimentally measured values of constant R infinity, R, T, C, and H, and the value of the magnetic permeability of free space, mu zero, we derive the key fundamental physical constants. Basic size unit A, that equals about 10 to the minus 14 meters. This is the minimum size in classical physics. There are no so-named Planck lengths and all these other quantum mechanical parameters. I don't know why they took them and what is the meaning of them. In classical physics, this is the basic size unit, 10 to the minus 14 meters. Forget about everything less than this number. Dimensionless Rydberg constant alpha. It's a very simple parameter. It's equal dimension Rydberg constant R with infinity, A as a basic size unit in power 1/3. That's it, simple like this. The constant alpha was later named Sommerfeld constant and later fine structure constant. Can you see that all these parameters were introduced in quantum physics, but they came from classical physics? They were not invented by quantum physics. It is classical physics. Electron rest energy that equals alpha Hc over A. And what is important, elementary charge E, it's exactly E squared equal to this equation. That's it. No quantum physics, no other parameters, only experiments based on the classical physics. All of these constants were determined or could have been calculated prior to the development of quantum physics. Quantum physics took it and used it. World-Universe Cosmology. World-Universe Cosmology is founded on three central concepts: cosmic medium, the carrier of all interactions in classical physics; universe created matter, continuously generated by the eternal universe; angular momentum, inherited from the eternal universe. The purpose of this paper is to demonstrate how physical constants and major cosmological parameters naturally emerge within WC. Why four spatial dimension observable world? To address the absence of a physical center of expansion in three-dimensional cosmology, often associated with the initial singularity, WC introduces the concept of the hypersphere world embedded in the four spatial dimensions. In this framework, the center of expansion resides at the center of the four-dimensional nucleus. The expansion of the nucleus stretches its three-dimensional surface, which constitutes the hypersphere world. Thus, there is no need to invoke dark energy. The continuous creation of matter arises naturally from the nucleus expansion in the fourth spatial dimension. You see, matter is produced homogeneously throughout hypersphere world. In WC, all major cosmological parameters of observable world depend on the dimensionless time-varying quantity Q that equals R over A, where R is the world's radius and A is the basic size unit. Quantity Q encapsulates the curvature of the world in fourth spatial dimension and serves as a fundamental scaling parameter. You see, it's very important to stress that it is fundamental scaling parameter. You can measure all the measurements in our space based on this parameter, referring to it. Energy density of observable world. In WC, the observable world is described as the Hubble bubble with the radius r equals to c tau, where c is the gravitodynamic constant, identical to the electrodynamic constant in Maxwell equation, and tau is the absolute time. It's very important to stress. We have absolute time in the all observable world, all the same, no difference, no dilation, nothing. It's absolute time. The observable world has an intrinsic surface energy density, sigma zero, that equals in our model Hc over AQ, interpreted as a temperature invariant surface enthalpy. I've done it in 2013. Following Nikola Tesla's principle, there is no energy in matter other than that received from the environment. The total energy of observable world is 4 pi r squared sigma zero. It's a very well-known classical equation. The corresponding average energy density, if we will divide this energy on the volume of this Hubble bubble, will equal to 3 sigma 0 over r, 3 rho 0 multiplied on inverse value of parameter q, which decreases inversely with radius r. Here, rho 0 is the fundamental energy density unit, and q is ratio of radius over A and ratio of age of the observable world divided on T0, where A tau is the absolute age of the world, and tau 0 equals A over C. It's 10 to the minus 23 seconds. It's the basic time unit. Let me stress one more time. This is the basic time unit, 10 to the minus 23 seconds. There is no Planck time. There is no Planck length. There is nothing. This is the minimum basic time unit, 10 to the minus 23 seconds, and don't talk about the times less than this number. Thus, Q is equivalent to Dirac's large number. It's variable, time variable, Dirac's large number. You see, matter is continuously generated by the eternal universe within the expanding four-dimensional nucleus. This occurs through the formation of universe-created particles, which annihilate in pairs to form ordinary particles. You see, particles carry angular momentum resembling microscopic air vortices. The rate of UC matter creation is proportional to the surface area of the Hubble bubble. Surface increased, energy increased. The surface energy density sigma zero can also be expressed as an angular momentum flux density, GH. Take a look, it's H over A squared T zero. It's exactly density, angular momentum flux density. So that the total energy of observable world is equivalent to the total angular momentum flux IH, that equals 4 pi r squared, the whole surface, multiplied on the flux density. Simple like this. Directed along the four spatial dimension, because usually it's a vector and it's along the four spatial dimension. In summary, WC reduces the world to two fundamental parameters, the dimensionless Rydberg constant alpha and the time varying quantity Q. That's it. The principle follows that the best theory is the one constructed from the fewest possible dimensionless parameters. It's exactly WC, minimum parameters. One of them belongs to universe, alpha, and another one, Q, belongs to our world. That's it. Critical energy density, it's a very important notion. Let me show you how you can calculate it based on classical physics only. The principal idea of WC is that the energy density of observable world equals to a critical energy density, rho critical, which can be found by considering a sphere of radius Rm, an enclosed mass M, that can be calculated by multiplication of critical mass density by the volume of the sphere. When observable world has the critical density, the Hubble velocity that equals h over Rm, h is the Hubble parameter, equals c over r, and r is the radius of observable world, equals the escape velocity, v escape. And I took this v escape squared well-known parameter, and I equal it to the Hubble velocity. This is a well-known parameter and calculated as in classical physics, and I equaled it to h over Rm squared, which gives an equation for rho critical 3h squared c squared over 8 pi g. Let me remind you, it's a well-known equation for critical energy density in general relativity, in quantum mechanics. I don't know where. But you don't need to use general relativity. You can use and you can find this equation based only on Hubble equation, on Hubble velocity, on Hubble law. Hubble law and very simple classical calculations give you this critical energy density formulation. It's very important to tell. You don't need to invent general relativity. You can do it based on Hubble law. That's it. This equation can be rewritten in such a way. It's very important. Well, my expression 4pg over c squared, that is a mu g, it's a gravitomagnetic parameter, multiplied on 2/3 of rho critical. This is the energy density of cosmic medium that equals r squared, c squared over r squared. Considering that h is inversely proportional to r, it is easy to see that gravitational parameter g also inversely proportional to r. We emphasize that the values of the main cosmological parameters g and h depend on the value of rho c cosmic medium, which is the characteristics of cosmic medium that is homogeneous and isotropic. It's a very important conclusion. There is no need to take all the energy density of the world. It's in homogeneous and in anisotropic and so on and so on. But our cosmic medium is isotropic and homogeneous, and all the physical laws of classical physics depend only on cosmic medium, on energy density of cosmic medium that equals to two-thirds rho critical. That's why I've done this, equation to show that all these parameters depend on cosmic medium only. According to WC, the critical energy density, rho critical, equals to rho observable world. Rho critical, this is equation I showed you right now, and rho observable world, I took it from the first calculations I showed you before. From this equation, we can get the following expression for the gravitation parameter G. Many times people ask me, where you took this value for this parameter, G parameter? I took it from the equation that rho critical equals to rho observable world. This is a very simple equation, and based on this equation, I've got the very important equation for G. There is no invention. There is no something from this kind. This is based on a simple classical equations. Interconductivity of primary cosmological parameters. The constancy of universe fundamental constants, including G, is now commonly accepted, although it has never been firmly established as a fact. A commonly held opinion states that gravity has no established relation to other fundamental forces, so it doesn't appear possible to calculate it from other constants that can be measured more accurately as it is done in other areas of physics. WC holds that there is indeed exist relations between all cosmological parameters that depend on dimensionless time-varying quantity Q. According to WC, the following parameters of observable world depend on Q. Newtonian parameter of gravitation. Right now, I calculated this parameter before. Hubble parameter that equals C over A multiplied on inverse value of parameter Q, and so on. H of the world, this is the equation for absolute H of the world's radius, this equation, critical energy density, concentration of intergalactic plasma, minimum energy of photons, temperature of microwave background radiation, and temperature of far infrared background radiation peak. This is the equation for this peak. You see what I mean? Not only Newtonian parameters, but all the major cosmological parameters depends on this parameter Q. It's a very important conclusion. And I revealed these relations between all these classical parameters, classical equations, where a basic energy E0 equals to RC over A. It's a well-known equations. In frames of WC, all these cosmological parameters are a manifestation of the world's curvature in the fourth spatial dimension. It's very important to tell that the fourth spatial dimension, and we have witnesses of them based on all these parameters depending on this. By the way, it's according to the Mach principle that local physics depends on a large-scale parameter, large-scale world. It's exactly Mach principle expressed in these equations. Directly measured cosmological parameters. There are only two directly measured cosmological parameters: the gravitational parameter G and the temperature of the cosmic microwave background radiation. Lee et al. Experimentally measured the most accurate values of G using two independent methods with accuracy about 11.6 part per million, which are in excellent agreement with the value G, compare apple to apple, predicted by WC in 2013. Can you believe it? In 2000, and they've done it to 2021. In 2009, Fixon measured the value of ambient temperature. This value, 2725181, with 30 part per million accuracy. It means that the most accurate parameter is G, 11.6, and temperature 30 part per million. And all other cosmological parameters could be in principle calculated based on the value of G with the same accuracy. Thanks to the revealed by WC interconnectivity of cosmological parameters, we show that G that can be measured directly makes measurable all cosmological parameters which cannot be measured directly. Gravitational parameter G and Dirac's large number Q. Considering equations in section 3, we have the following equation. Let me remind the same equation I've done already 2 times. It's so important that I'm ready to repeat it many times. An average value of gravitational parameter G average of experimentally measured values by Lee et al. It's about this value with accuracy, as I told you, 11.6 part per million, allows us to calculate the value of Q average based on the value of G average. This is the equation. You can see it's a real inverse equation of the same equation for G. Q average equal this parameter multiplied on G average in -1. This is the value of this so-named large Dirac number, about 10 to the power 40. He not calculated. He done some ratios of different parameters, and he found that it must be around 10 to the power 40, this ratio between the classical parameters and quantum parameters. In my case, in WC, it's not evaluation. It's an exact calculation of this number for the present epoch, about 10 to the power 40, with the accuracy of this parameter as it is written in here. Below, we will use this value of Q average for a calculation of all cosmological parameters. Leveraging interconnectivity of primary cosmological parameters revealed by WC, we demonstrate that the gravitation parameter G average, which can be measured directly, enables the determination of all other cosmological parameters that are not directly measurable. Using G average, we calculate the radius of the curvature R as follows. From G average, we calculate U average. I showed you before. Then we can calculate R that equals A multiplied on this value, and it is about 10 to the power 26 meters. It was not evaluation. It is not estimation. It's exact number based on the developed theory. Hubble's parameter and age of the world. The most important parameters in cosmology are the Hubble's parameter, H0, means in the present epoch, and the age of the world, A-town, which can be calculated by the following equations. H0 has some standard parameter multiplied on G average, and it's equals 68 kilometers per second per megaparsec. And age of the observable world equals to inverse value of parameter on Hubble parameter H0 that equals 14.226 billion years. We emphasize that the Hubble's parameter H0 and absolute age of the world are determined by the experimentally measured value of G average. You don't need anything else. You don't need any other assumptions, let me tell you in such a word. You can exactly calculate with this accuracy up to 5 digits. We emphasize, okay, According to WC, the value of ash should be measured based on microwave background radiation only. Why? Because microwave background radiation belongs to cosmic medium, and cosmic medium is homogeneous and isotropic. That's why all these laws, they are valid for the whole world. Cosmic medium, it is a savior of classical physics. You don't need to invent any other parameters. Our parameters we measure in our vicinity, valid for the whole world. According to WC, is in excellent agreement with the most recent measured value in 2021. Okay, take a look. I gave the 5 digits for this value, and in 2021, it was calculated by experimentalists 68.7 plus minus 1.3 kilometer per second per megasecond, using only NBR data. Compare what was calculated 8 years before and what is measured 8 years later. Temperature of microwave background radiation and electron to proton mass ratio. Considering the equation in section 3 for temperature of microwave background radiation, I showed you before, we have the following equation for ratio of mass electron to proton mass. Can you believe it? You have this equation based on the experimentally measured temperature of microwave background radiation and measured Q average based on the measured gravitational parameter. And then based on these two measurements, you can calculate even this ratio. There is no cosmic medium, there is nothing. WC, being a classical model, introduces classical notions only from the moment the first ensemble of particles emerged in the absolute time, about 10 to the minus 18 seconds. This is the expression for this time, which defined by the value of Q more than alpha in the power minus 2. Inverse value of alpha squared, that is equal 18,718. That's why 10 to the minus 18 seconds. There are no shorter time in classical physics. There is the minimum absolute time. This is the unit of the time T0, and absolute time when you have the first ensemble. You can introduce notion cosmic medium, and only then you can start talking about the classical physics. Time, space, and gravitation are intrinsically linked to the impedance parameter of the medium, Zg, that equals mu g and multiplied c, the gravitomagnetic parameter mu g, and the energy density of cosmic medium. We talked about this energy before. It's 2/3 of rho critical, respectively. Consequently, time, space, and gravitation cannot be discussed independently of cosmic medium. There is no cosmic medium, there is no any parameters, including time, space, and gravitation. In frames of WC, mu g can be calculated based on the value of raw cosmic medium. Mu g, it's a well-known value equation for pi g over c squared. It's an electrogravitodynamic. It's written this equation. And we can transfer it to the value rho cosmic medium over c squared multiplied on dimension transposing parameter p that equals to this value. There is no miracle, there is nothing. I split this value, what I calculated before, on two parts. This is a part depends on energy density of cosmic medium, and this is the sum coefficient, and the value of this coefficient, this one. The gravitational parameter g equals to the same rho cm, rho cosmic medium, divided on 4 pi, multiplied on the same dimension transposing parameter, p squared. Using a substantial degree of freedom when it comes to choosing the dimension of mass, We multiply the mass by P and divide the impedance of the cosmic medium by P. Following this approach, we found the gravity-magnetic parameter of cosmic medium, mu cosmic medium, that equals 1 over r. This is inversely proportional to the radius of observable world. You see, you have your
5 minutes. 5 minutes.
okay. I will this one finish, and then I have a very important table. I will talk next 40 minutes. It's okay. Okay. Thank you so much for warning. I will finish this section, and then we will go to the other section next the 40
Okay.
minutes. Okay, very important. We have our parameter mu g, that is a magnetic parameter of our cosmic medium, and the value of it depends on the radius of observable world. You see, there is no this medium, there is no this radius, there is nothing to talk about, there is no space. And the impedance of the cosmic medium, ZCM, that equals mu, this value of mu cosmic medium multiplied on C, that equals to H, our Hubble parameter, and which equals to tau inverse value of tau, inverse value of absolute time. There is no impedance of the cosmic medium. There is no absolute time of the world. This is the equation shows this is a correlation between one parameter and another one. Gravity under WC is not an interaction, but rather a manifestation of a cosmic medium. This perspective aligns with the Lissajous theory of gravitation, which in WC is based on UC particles referred to as xions, with the rest energy 5.3 microelectron volt. It's a very light particle. The energy density of cosmic medium constitutes 2/3 of the total energy density of observable world. All physical laws are determined by cosmic medium, which is both homogeneous and isotropic. Indeed, cosmic medium emerges as the cornerstone of classical physics, a savior of its principles. Let us not discard this profound concept with the tide of modernity. We must not throw the baby out with the bath water. Physical parameters corresponding to the characteristics of the eternal universe and cosmic medium are depicted in Table 1, and I will show this table. This is a table we will discuss next our session. Table 1 depicted analysis of this table shows that all major physical parameters determined by their characteristics. I will talk about this next session.
All right, you got 2 minutes. 2 minutes.
Yeah, 2 minutes. I can read conclusion, or I can read it after.
Why don't we stop now, and then
I agree with
you
you.
can do the conclusion in the next session. Okay. Anybody have any questions here? We got like just barely a minute. Okay, I do have a comment. I like this really a lot. I really think it makes it a lot clearer what you're doing, and ties a lot of things together. So I really like this presentation quite a bit.
So much, sir. It's only thanks to you. I started very clear picture of my model with all these new notions, absolute time, cosmic medium, and all this stuff, particles, world universe particles. 1.5 years, you started to ask me the right questions. It's a result of your right questions. I tried all the time to answer, first of all, to you. You're my boss, super boss in this model.
Okay, well, anybody, I like the idea of this cosmic medium, and you're tying all this stuff together in a set of equations, and it's based on a kind of a set of assumptions which you don't really go into, but they're pretty clear what they are if you think about it. You have a cosmology that's based on a real physics. Okay, I got cut off. I was praising your model as being real physics. And one of the things I noticed that I've been on YouTube looking at a lot of cosmology and physics videos, it seems that one of the big criticisms is that it's all based on mathematics, it's all idealism. It's not really, the models are all just ideal mathematical models, not really physics at all. I think that's one of the criticisms of the way modern physics is being done.
So much. You're absolutely right. What is important is experimental physics. Physics is the science. It's not mathematics. Mathematics in a service for physics. It should be some experimental parameters, experiments proving, confirming your theory. This is a very important issue. Everybody forgot that physics, it's experimental science. Experimental many times. And all the parameters I calculated and compared my theory with real measured calculations. And what is found even these equations based on two parameters only, G average and temperature of the microwave background radiation. You can measure them. You can calculate all these parameters based on a real results of experiments, not out of the sky. Let's continue.
Okay,
Let me Yes, sir.
okay, I guess we can continue on if you share your screen.
Yes, I will. I will. Please allow me to share. Table one, it's a very important point of this special report, special presentation, because, as a result, I will tell you why. Because we have some parameters in our physics. I ask myself question, where did they came from? Why we have these parameters? Who specified them? Who put them on our shoulders? And why we work with these parameters? And what is important, I want to now demonstrate that all these parameters inside of eternal universe, the characteristics of it, and cosmic medium. That's it. Simple like this. It's not our random numbers. No, it's numbers prescribed by eternal universe and cosmic medium. Simple like this. This is exactly the value I want to discuss with you in details. One
Do you
physical
want to go to the conclusion first, or do you want to
conclusion after as usually, because I refer to table one and conclusion will be
So we're
after,
going to
because
talk
I
about.
wanna first of all to show the correlation, why we have the parameters, what we have in our classical physics, based on what, where they came from.
Okay.
Characteristics of the eternal universe and cosmic medium. Creation of four-dimensional nucleus with extrapolated radius RA. I told you about this creation as a fluctuation with radius, extrapolated radius A. It's a basic size unit A. You see, these parameters came from the beginning of our world, from the first fluctuation, from the size of this fluctuation. Creation of UC particles with rest energy alpha in power n multiplied on E0. We have created UC particles. I told you about it. These UC particles, they have basic energy unit E0 and constant alpha with in power n from -2 up to 6. I have multi-component ensemble of particles. But what is important, this E0 and alpha came with these UC particles. Creation of total energy of observable world. How much energy we have overall? It's 4 pi E0 multiplied on Q squared. This is a parameter that equals R over A. You see, E0 we came from here, and Q squared, it's a parameter, large Dirac parameter in square. We can calculate the whole energy based on these two values. And Q can be measured by, I remind you, with G, with gravitational parameter. Creation of angular momentum with GH, it's a flux density of angular momentum, A squared to 0. This is a flux of angular momentum from eternal universe along the fourth spatial dimension to our world. Out of this parameter, it's a unit of angular momentum flux density. We have basic angular momentum unit H, Planck constant. Planck constant came from for us from this flux density, angular flux density, because we must have angular momentum inside of our world. Let me remind you, all macro objects, all our objects around us, they are rotating. You must have angular momentum. Who provided it? Angular momentum provided by the eternal universe, according to this equation. Impedance, many times I talk about it, it's equals to the tau in -1, inversely proportional to absolute time. You see, absolute time came for us as an inverse value of impedance parameter. Magnetic parameter, mu, is inversely proportional to radius of our curvature. Radius of the nucleus, r, equals to inverse value of magnetic parameter of cosmic medium. Impedance to magnetic parameter ratio. It gives us gravitodynamic constant C equals Z, impedance, divided on magnetic parameter. You see,
That's not the
nucleus
speed of
radius.
light.
I'm sorry?
Sorry to interrupt. C there, gravity to dynamic constant. That is not the speed of light. It's something else.
No, forget it. Speed of light, it's bullshit. Many
Yeah,
times
I
I
know you
told
don't
you.
accept it. The speed of electromagnetic radiation. Let's not argue about that. It's just you've
Speed of
used the symbol C.
electromagnetic radiation belongs to Maxwell equation, electromagnetic radiation. This is a gravitodynamic parameter C that's equivalent. It's equivalent to electrodynamic, not equal. Let me tell you, I didn't develop, I used gravito-electromagnetism. It was developed in 19th centuries too. And according to this theory, C is a gravitodynamic constant equivalent to electrodynamic constant. Having said, he died. He was a genius physicist, genius, a Great Britain English physicist. Even he put the present equations, Maxwell equations, as we learn it in our textbooks. Before him was mass. He wrote these equations. He thought that this equation he can use for gravitation too. And he was a genius, you know. I have no words about him. He done so much, and nobody knows about Heaviside. I opened for myself so many genius physicists in classical physics, and all of them forgotten by mathematicians because they don't know them. They don't care about these ideas. They care about only equations and how to solve them, and that's it. Simple like this. That's why, you know, it's not my proposal. It's Heaviside, done more than 100 years ago. And I used all these genius ideas from classical physicists. Nucleus radius to basic size unit ratio. Dirac's large number Q that equals R is the radius I told you about before. Divide over A. Over A. This is a nucleus radius to basic size unit ratio. You see, Dirac's large number, it's why? Because we have our world with nucleus radius R, and we have A as a starting point in fluctuation in the eternal universe. And then we have this large Dirac's number. Impedance, one more time with this value. Hubble parameter, it is the expression exactly of impedance of our cosmic medium. Can you believe it? It's so simple. Hubble parameter, it's not out of the sky. It is the expression of the impedance parameter of cosmic medium. World time based on impedance, absolute age of the world that equals to this inverse value of impedance parameter. This is the age, and this is the value of it, tau. The world hypersphere of four-dimensional nucleus. Finite volume based on the volume of this hypersphere. You see, it's a hypersphere. You can easily calculate what is the finite volume of our space, of our hypersphere world. It's more than Hubble bubble. Hubble bubble is three-dimensional, our world. The absolute observable world, 3D dimensional bubble, volume of the observable world, as we know, spherical volume for third pi r cube. How many observable worlds we can have in finite value of the hypersphere world? Three. We have three parallel observable worlds. Can we see them? No. Can we talk about them? No, because we are experimentalists. We live in observable world, and this is the value of this radius, the same as the radius of the nucleus in fourth dimension. Even this radius belongs to the fourth dimension, to four-dimensional nucleus. That's it. That's why in a third dimension, we have the same parameter, R. Energy density of the cosmic medium. This is the expression for it. Gravitational parameter G that equals this energy density of cosmic medium over 4 pi. That's it, simple like this. There is no invention from some, equations. It's expression of the energy density of cosmic medium. Electron-proton intergalactic plasma. We have intergalactic plasma. I didn't talk about it. But what is important, energy density, this value, intergalactic plasma, and this constant alpha, really, it equals to rest energy of electron divided on the energy unit E0. You see, there is no even need to talk about Rydberg constant, about this ratio, about this dimensional Rydberg constant. If you have your electron-proton intergalactic plasma, and we have it, it's experimentally confirmed, and you have your electron, based on this electron, immediately you have this constant alpha. You don't need to go to any other place. Please take your rest energy for electron, divide on this unit of energy, and immediately you have this alpha. For our convenience, I told you about this, dimensional Rydberg constant, because it was before classical physics. It was before my theory. That's why, I cannot tell in other words. But now I can tell electron, proton, intergalactic plasma. If you have it, and we have it, we confirm, you have immediately this parameter alpha. There is nothing unique, nothing magic. It's a ratio of one particle to the standard unit of energy. Temperature of microwave background radiation. We have background radiation as a part of cosmic medium. We have a temperature of it. Immediately we have this ratio, electron to proton mass ratio, ME over MP. Well-known parameter, but it came where? Not from calculations, not from some other place. It came from the temperature of microwave background radiation. You see, in this column, there are characteristics of the eternal universe and cosmic medium, nothing else. And in here, we have all the major parameters, started with the basic size unit A, with constant alpha, and this ratio, so with G, with everything. I would like to stress the value of this table. The value is very simple, guys. We are not inventors of all our classical physics. All these inventions done by eternal universe and cosmic medium we have around us. That's it. And parameters, and there are no parameters of our eternal universe. There are only one characteristic of universe: creation, 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 creation only. There is no space, there is no time of eternal universe. It's eternal. By definition, there is no time. Eternal universe. And the only one characteristic of it, it's a creation of nucleus, creation of particles, creation of angular momentum, and all this stuff. And then, based on this characteristic of eternal universe, we have all these very important parameters for classical physics. And the same story with cosmic medium. You see, there are only parameters of cosmic medium, and all the other notions, definitions, parameters, R, tau, and all this stuff, based on all these cosmic medium parameters. That's it. Simple as this. Please pay attention to this table and see we are in hands of cosmic medium and eternal universe. That's it. There is nothing to talk about. Now I'm ready to talk about the conclusion. WC demonstrates that the fundamental physical constants and major cosmological parameters of the observable world can be derived from a minimal foundation. Foundations are eternal universe and cosmic medium. The dimensionless Rydberg constant alpha, this is the expression for it, or it might be, as I told you, energy density of electron divided on absolute energy, on unit energy, and the time varying scaling factor Q that equals R over A form the backbone of the model. These are the two parameters, one of them alpha, another one Q. And all the other parameters depends on these dimensionless parameters. Absolute age, Hubble parameter, critical energy density, and other major cosmological parameters emerge naturally from these quantities rather than being introduced as adjustable inputs. Can you believe after any new experiment, general relativity, you must adjust all these parameters? I hate it. You have your mathematics, give me the parameters. No, you will have new results, you will have a new parameters. Can you believe it? What kind of physics we have, what kind of fundamentals, basic we have, if we have all the fluctuation parameters of this. The framework avoids the need for speculative constructs such as dark energy, inflation, or an initial singularity, replacing them with physically grounded mechanisms rooted in the expansion of a four-dimensional hypersphere world. Comparisons with observational data, including Hubble measurements, CMB derived cosmological parameters, show strong agreement with WC predictions. A lot of predictions are done in 2013 and in 2008, 2018, 11, 13, it doesn't matter when. All these predictions were confirmed by experimental results. It's very important to tell. It's not only equation, it's not only model. On the contrary, all the parameters, what I showed you, especially this one, let me come back to this parameters. All these parameters, all of them were confirmed later. I calculated them based on the model. I started development of this model in 2013. And then one by one, they were confirmed by experimentalists. Thus, WC offers a predictive, coherent, and testable alternative to the standard Big Bang model based on classical physics principles and a minimal set of dimensionless parameters, alpha and Q. That's it. This is the conclusion of my presentation. I am ready to discuss any parameter, any part of my presentation, because I put all myself into this short 7 pages presentations. Thank you so much for your attention. Thank you very much for being together with me today. I tried to share with you my excitement about the conclusion of my model. It's model, it's not theory. I invite all the people try to use this model, this basis of classical physics. I can talk about the classical physics, it must be changed too. But if you have any questions about classical physics, I'm ready to answer them too. It's up to you. I'm ready now, based on this presentation, when I put all the notions, all the parameters, I showed where these parameters came from, for myself, and I hope I showed you to you. I'm ready to answer any questions about classical physics, what I know, but it's not final. No, it's only basis. Please use it and develop based on a new platform. Thank you so much for your attention. I'm so happy to be with you today.
All right. Well, thank you. I think this is very impressive. I like this a lot. It clarifies a lot of things that I really didn't quite understand from your previous presentations. I can see that there's a lot that's not covered, that you have to kind of go back to the previous presentations. But what you've done is you created a physically based cosmology rather than what I would call a ideology based cosmology, which is based on the general relativity, quantum mechanics, and there's a lot of argumentation now going back and forth between the fact they've given up apparently on string theory and these quantum unification attempts to unify quantum mechanics with general relativity. And it looks like that's just not working out for them. So this concept of starting from ideal mathematical theories and building a universe from those theories is not really working out for mainstream physics. And this is a different approach, which really tries to, I think I would call it a realistic model, a cosmology of realism-based cosmology. It's not, as you pointed out pretty effectively, it's not based on mathematical metaphysics ideas. And a lot of these models, they depend on, you construct a model like in general relativity and cosmology and particle physics. They've got all these equations, but to actually make the model work and to actually make predictions, they have to pull these parameters out of where do these parameters come from that make the model work? They just pick them out of the sky, or they figure, oh, we experimentally verified this is what this parameter value is. And you've basically, shown that that's not really necessary. This whole business of models with numerous parameters in them that need to be adjusted in order to give the correct answers.
So much, Harry. It's a very good for me, Ron, I have a good feelings from you right now, because I tried all the time to answer your questions. As I told you, you started 1.5 years ago.
Okay, well, thank you for that.
Let me tell you my understanding of general relativity, guys. I'm not blaming all the physicists. There was a genius, Einstein, who proposed general relativity. There is this inflation, all these new characteristics of this model, because there was nothing from the beginning. The guys, they are trying to save general relativity approach wrote by equations or by Einstein. And all the parameters of general relativity came later. Inflation, all these, parameters. Do you know how many parameters you have inside of general relativity? over 20, and all them varies is depending on the experimental results. What kind of theory? They are trying to save their dead body. General relativity, it's a dead body, it's equation, it's mathematics. And I'm not blaming physicists. They are trying to do their best. They have to invent these parameters. Dark energy, what does it mean, dark energy? Nobody knows, but they have to use 70% of it to save them. And all this stuff, all the other parameters. Dark matter, where they came from? From the beginning, it was only electrons, protons, even all the nucleus. That's it. Neutrons, that's it. Suddenly, you have your energy, dark matter, you have your dark energy. Where they came from? Nobody answered even this question. They need it and they use it because they're trying to all the time to save mathematics. They are not physicists. They're mathematicians trying to save the main idea prescribed by Einstein equations. Simple like this. Stop be mathematicians, start to be physicists based on experimental results. It's exactly what I started to do 24 years ago. My very first paper I downloaded on Dijkstra in 2013 because nobody wants to publish this paper, to publish it, forget it. I tried twice to put it in archive, twice, and one time my chairman of my journal, he recommended my published paper by him. No, it doesn't work for us. It's not. They put all the stops for any new ideas, new theories, new models. Forget it. You must be inside of general relativity and put a new parameter, new ideas to save these equations. Genius equations. I have nothing against equations, but I'm against mathematics behind these equations, and there is no physics at all.
Well, this is a big threat to the academic people who publish papers based on, they've got a lot of mathematics and create a lot of, and it's just they crank out papers. I think they want to be able to construct. They have a lot of, I spent the last couple of weeks. There's a lot of videos on. There's one particular video channel whose name I can't really recall right at the moment, where he has a lot of videos where he interviews the latest experts in physics. But as you say, they're not really physicists. They're more doing philosophy of physics and based on mathematical calculations. And, you can they talk about some really strange, bizarre, there are a lot of really strange and bizarre proposals that they're talking about as if, this is really, really science, but it really strikes me more as philosophy parading around as science. That's not that philosophy is a bad thing, but it's driven more by metaphysical ideas. They're trying to come up with, where time comes from, what's the origin of time, what's the, strange things that don't really seem like they belong in the realm of physics. But they seem to be, harbored in the academia, which is all about mathematical manipulations. That seems to be what physics is today, is mathematical manipulations. How can you create a mathematical theory of the universe or whatever? Not really based on physical reality, it seems to me.
So you're absolutely right. But let me tell you, we talked about the special relativity many, many times, including the last talk yesterday. We are talking about some mathematics, about logic, and Harry, I was not so interested in the presentation yesterday, and I will tell you why. Because mathematics behind of it, Harry already gave his evaluation of the mathematics. It's not even theoretical mathematics. It is wrong mathematics, wrong. And nevertheless, we continue to talk about special relativity. Why we need special relativity? There is absolute space and absolute time. There is no connection between them. It's two different stories. That's why this relative space, relative time, dilation, subtractions, and all this stuff, it doesn't matter how to name it. It doesn't exist. It's mathematical tricks. That's it. There is space and there is time. Time absolute. All the same time in all the world. We have even our speed of our solar system, our Mother Earth, against microwave background radiation. Numbers with 3 digits at least, and so on and so on. Why we need to talk about something speculative? Well, what will happen to an astronaut if he will come back after 30 years, or he will be only 2 years old? Forget it, guys. There is no meaning for it. It's only logic. It's only logic training. But Harry already gave the logic evaluation, estimation, and he told mathematics wrong. Yesterday, the same story. He started with x prime 0, t 0 at the same time. Come on. Harry, I don't know. You must, put your paper in all the journals and to show, guys, stop already bullshits with mathematics only. No, we can continue and continue. Guys, classical physics belongs to Hallelujah, baby, because there is absolute space and absolute time. There is no relative time. There is no relative space. There is no four-dimensional space. What kind of four-dimensional space we have in general relativity? The time axis with I component. It's not four-dimensional. It's a four-manifold. It's only mathematical expression of these equations. That's it. There is no physical meaning of this so-named four-dimensional space-time. It's not four-dimensional. It's four-manifold. And people, mathematicians, they don't know the difference between four-dimensional and four-manifold. Come on, guys. What kind of physics we have right now? I mean classical physics. By the way,
Well,
gravitation
I think
and cosmology belongs to classical physics. Yes, sir. I'm sorry.
yeah, okay, if I may come in. Yesterday, I think he was actually indicating that the mathematics doesn't work for, say, Lorentz theory when compared with experiment. And I think the mainstream people would ostensibly agree with you, actually. Now, they may not be carrying out what they claim, but I think they say, when I sort of read their publications, they say, general relativity, yes, there's a slight doubt there because it's rather mathematical and we only have some observations which indicate it. But special relativity is as near it as possible certain. We know it's certain. We will not brook any criticism of special relativity because it has a panoply of experiments behind it. Now, I think we'd probably agree that they're actually hypocritical. They're saying something and they're not actually following it through because there are many experiments which many of us would say contradict special relativity. But they would agree in principle with your, they wouldn't have any argument with you. They would say, yes, it must be based on experiments. And the mathematics is secondary. It's a backup to that. It's not a primary thing. And that's why they actually concede that there's a slight question mark in general relativity because it cannot be comprehensively validated experimentally.
Well,
Let me
I did
tell
want
you
to
about
mention here now that, okay, go ahead, Vladimir.
Let me talk about, because I was saturated yesterday with this special relativity. I hope the last time I will not attend new meetings about them because there is no meaning for it. Let me tell you, I'm experimentalist. I ask him the question, do you know that there is some, plasma around our Mother Earth? Oh, there is. They took into account this plasma, they subtracted. You see, the conclusion that there is no ether based on subtraction from the results, experimental results, some influence of our surrounding plasma around ionosphere. Can you believe it? You want to do conclusion based on calculations. Let's subtract what we can see right now, and then we will see that it's an empty space. There is no ether at all. I don't believe. Where is the logic? Who is the boss? Experiment or your subtraction? Because if you have your goal, objective, to prove that there is no ether, you will do everything to confirm it. Let's subtract something, and that's it, simple like this. The next very important point, I hated speed of light. I asked him the second question, two questions only. I asked him yesterday, what does it mean, speed of light? He didn't answer it because everybody uses c and nobody thinks about what does it mean, speed of light. In Maxwell equations, there is no speed of light. Some idiot put in Maxwell equations right now c as the speed of light in vacuum. There is no speed of light in Maxwell equation. There is electrodynamic constant c measured by genius people before Maxwell, even before Maxwell equation. They measured, they found this parameter. Why it is so important? Because I am so tired about them. Because even this conclusion about no ether, it doesn't belong to this special relativity. You cannot prove it. You cannot confirm. If you subtract something, you need to subtract to prove that you have no ether. The next very important point, speed of light. There is a speed of electromagnetic radiation. I asked him the question, what is the wavelength of these instruments, GPS instruments? And he did answer. You, based on this experiment, you proved your Lorentz doesn't exist, ether doesn't exist, and so on, based on some results, and you don't know even details of it. What is the frequency? What is the wavelength of it? I don't know. Immediately, I reminded to you guys, I told you many times, there are so-named fast radio bursts. They exist at least maybe 15 years, a lot of papers about them. There is a dispersion of radio waves coming to our radio telescopes. Higher frequency, less time of passing through the space. And these components, you can measure the components wavelengths, frequency, and you can calculate even the concentration of intergalactic plasma. I was very impressed. They've done it. And this concentration of intergalactic plasma, according to my calculations in 2013, can you believe it? And my papers, I showed you, there is intergalactic plasma. There are fast radio bursts. They prove, they confirm there is no empty space. There is microwave background radiation, everybody knows. Intergalactic plasma, part of this cosmic medium, and so on and so on. Why you cut fast radio bursts? Why nobody wants to take care about these results for radio waves? It's well known. I cried about this. There is no result. One more time, speed of light, speed of light. And nobody understands even what does it speed of light. That light, it belongs to a very narrow part of our spectrum. Forget about the light. Infrared light, no, it's not light. It's infrared radiation, radio radiation, and all this stuff, radio wavelengths. No speed of light. And he done great job. He done great report. But the principal points of his report absolutely wrong. To subtract something to have no ether. And the second one, speed of light.
I think you've misunderstood it. He didn't say there was no ether, actually. No,
I'm
no,
sorry?
you've said a number of things that I think are incorrect, Vladimir, there. But anyway, Harry, sorry, go ahead.
All right, we got 2 minutes. We can argue about that later, I suppose. I think the real issue is that kind of special relativity kind of turns physics on its head, and physics goes from being an empirical, experience-based discipline to one that's totally mathematically oriented. And so you can create, the world becomes what the mathematics tells you the world is, rather than what the facts of experiments tell you what the world is. And so Einstein sort of created that. And then that sort of then morphs into quantum mechanics, which says the world isn't really real anymore. And then, so now you're in in a big quandary.
Yeah, you're absolutely right, sir. We are not real too. We are holograms, you know, there are such idea too. I do
Yeah.
believe it. I do believe that all of us exist, really exist, guys. Uh, I'm very sorry
Okay,
for my
so we're
emotions
almost
as
ready
usually.
to cut off here. So, okay, we can discuss this in the next session.
Yes, let's continue the discussion because I would like to ask you questions, guys. If something I've done not so good, you know, I didn't clarify and so on and so, it will be very good for us to discuss what I proposed to you. I
Okay, we're recording. Okay, I'm not sure if Vladimir is taking a break, I guess. Um, does anybody want to make any comments or
Well,
he was
I have a couple
asking
of, I
he
have a
was
couple of,
asking if there were any areas that could be improved or any things that weren't clear. He was asking for how he could improve his presentation.
I have a couple of questions when Vlad returns.
Okay. Um,
Oh, he's
um,
got a coffee.
I actually
yes, I trust him.
my
Yes.
reaction to his presentation was I thought it was a lot clearer than the previous work that had been done, and I'd like for other people, if they would, to comment on how they felt about that. I thought it was clarified a lot of issues that I wasn't really clear about in my mind. I thought it was clarified some of the things that he's been talking about, and so I'm wondering if other people basically had the same reaction that I did on
I
Sure,
thought it
let
was
me share
clearer.
the screen. If you have any questions, let me give you a text and whatever you want to discuss, I'm ready to come back to all the issues. Let me tell you, the most difficult is to write something shortly. I thought about this, you know, presentation a lot, believe me. And I'm looking at this, you know, presentation as a final presentation of my model. Why? Because I put everything what I know about philosophy, about physics, like an experimental science, into this paper. And I explained even myself that we have some physical parameters, where they came from, why we have these parameters, not some other parameters. You see, it was my main question to ask. What is going on? Why we have this and this and that? And all of them depends on characteristics of the main players of our world, eternal universe and cosmic medium. Guys, I'm ready to answer all your questions. Whatever you will ask, I will try to clarify, even about classical physics. We must rewrite even textbooks for classical physics too, because it's obsolete too. We must put a new ideas in classical physics because it's a different world right now we have. And what is important, Dirac in 1937 was absolutely right. The way to go to a new classical physics through cosmology. It seems to me that I developed this basis of cosmology. Now we can talk about the classical physics. What's new in classical physics and why? Especially entropy, energy, and all these parameters, and homogeneity, and all this stuff. You know, everything what we invented for classical physics right now from mathematics, it's very important to put on a experimental basis results. You know,
Can we go to questions
ready
now?
to answer all your questions, guys. Let's
that. Okay.
continue my excitement about this, you know, presentation and final report about my model.
Okay. Jim's been antsy to ask some questions.
Yeah, the your minimum length, as I understand it, is about 17 or 18 femtometers. Is that correct?
10 to the minus 14 meters. It's about 10, no, 7 maybe femtometers in your parameters, because I don't know femtometers, I know meters, you know, because I'm following system C, you know this.
Well, I'm
international
calculating
system.
that it's about 17. Now,
Okay, whatever.
People did different measurements of proton radius gets you into the 1 femtometer uh, level. And this is based on scattering and other day data, um, so that there's a body of experimentalists who believe that the radius of the proton, the particle which is mentioned in your work, is about 1 femtometer, and that's an order of magnitude less than your minimum length. How could this be? Do you reject the work of these people, or what?
I knew
Good
you were
question.
going to
Thank you
ask
so
this
much.
question.
It's a very good question. Let me tell you, first of all, basic size unit about 10 to the minus 14 meters. It's a basic. It's not, it's minimum, but it's basic for classical physics. Classical physics started at the length, at the size, about 4 orders of magnitude higher, larger. It's about 10 to the minus 10 meters only, classical physics. I showed you why we have 10 time 10 to the minus 18 seconds, and at the same time, we have the nucleus radius about 10 to the minus 10 meters. This is the beginning of classical physics,
Well,
beginning even
the,
later.
the, the scattering data, with all due respect, used Newtonian ideas of classical physics, and they're coming up with about a 1 femtometer radius of the photon.
Yes.
And
It's
so
exactly my
I'm just
point.
wondering how you reconcile this data. These are quite reputable, competent experimentalists, and this is widely known data with your minimum
Yes.
length.
Jim, it's a very good question because, from my point of view, there is a border, solid border, concrete, between classical physics and quantum physics. What I showed in
Well,
my
but I'm not
presentation,
asking about quantum physics. This is
yes,
Newtonian
yes,
physics.
but you
The
cannot use
scattering data
Newtonian
is
physics
not
for
quantum
proton.
physics.
One sec, you cannot use classical physics to quantum physics. This is exactly my point. You cannot use equations we have for classical physics for the quantum objects like electron, proton, and all this stuff. That's why whatever they're doing in quantum physics, it's up to them. But they use classical physics only. Let me tell you, today I told you, even the first parameters, the first numbers, notions in quantum physics, they came from classical physics. I showed you these parameters based on
Well,
experiments, classical,
Vlad,
classical only.
you're labeling this as quantum physics, which is really an editorial comment. I'm referring to experimental facts, not how one labels them. And the Newtonian physics used to determine by scattering work, this is classic physics. This was published back in the last century. This scattering data gets you into the 1 femtometer range, so that the only thing that I can conclude is that your theory just does not include this data, or it rejects I think you need to give a criticism of this data, or revise what your minimum length is.
You know what? First of all, I didn't put even word minimum. I put unit. It's unit of size. That's it. Like 1 centimeter, 1 meter, whatever. We have it. That's it. Simple like this. The next point, I will not criticize quantum physics at all. Never. Because I am not expert in this business. Maybe there is a scattering of some particles on some other particles, but all the calculations based on classical physics equations, they are not valid for quantum physics. For quantum physics, let me tell you, there is no space, there is no time, there is none. These even space and time notions arise with cosmic medium only. That's why for quantum physics, for quantum objects, I don't know what they're talking about. What kind of size, what kind of time they have. There is no such notions for them at all. This
Well,
theory might be only mathematicals like yours. I told you many times, your theory might be as a part of quantum physics. There are no space, there are no time, there are some jumping from one point to another one. It's up to you, whatever you're doing. I have my friend Felix left. He developed his theory based on operators only. There is no space and time. I agree with it. It might be different quantum physical principles based on mathematics only. And even continuous mathematics, you cannot use it. You cannot use it. The main killer for physics is mathematics, in infinity in mathematics,
well,
limit in
with all due
mathematics.
respect, I won't push this point much further because I don't think we're getting anywhere. But I think Roger Anderton would call this moving of the goalpost. We just had a presentation in which this 17 femtometer value was characterized as a minimum length. And now you're saying it's not a minimum length, it's just some length that you came up with. So the question is which is it? And so within just the range of this today's presentation, we've changed what the content of the presentation is. A related question is your minimum length of about 17, 18 femtometers. Is that the highest possible energy for a gamma ray in terms of its wavelength? Or are there more energetic gamma rays which have been observed? I don't know offhand what the answer to that question is observationally, but it's a related question. Are there gamma rays more energetic than what your so-called minimum length would suggest as a wavelength for those gamma rays, indicative of their energy? Well, thank you.
Gamma rays in my model is the result of self-annihilation of universe created particles. The biggest particle, the largest particle in my model is about, let me calculate right now, it's about, yes, 1.3 tera electron volts. Directly, one particle, 1.3 tera electron volt, self-annihilating with the same partner, give us gamma rays with this energy, rest energy, 1.3 tera electron volt. What does it mean, wavelengths for gamma radiation? I have no clue, because wavelengths, it is a parameter of ensemble of particles. I told you many times about double slit experiment and all this stuff and so on. That's why even invention of these wavelengths for gamma particle, for gamma 1 particle, it doesn't work for me. Wavelengths, it's a parameter, classical. You must have ensemble of some particles. Only then you can introduce the notion wavelengths as it is in classical physics. That's why energy-wise, you have only this if you have two particles. But if you have ensemble of these particles, suppose there 1,000 of them, and they will interact with 1,000 the same particles, I mean universe created particles, like a package, one and another one. Then you can generate this gamma radiation with much higher energy, no problem. Everything depends who is a part of this self-annihilation. Two particles, 1.3 tera electron volt max. If you have your packages, some ensembles together, they interact with each other. It might be much higher energy, much higher. Answering your question, but don't introduce and don't talk about the wavelengths, because as I told you many times, wavelengths, it's a classical notion.
Well, that last statement, I don't see what the sense of that is. Why we're prohibited to talk about a certain item.
His theory doesn't apply below that length that he's talking about. I think is the simple answer. So the length is, I knew this was going to come up, 10 to the minus 14 meters. So anything that happens before that or smaller than that isn't in his theory. Does that help you?
Yeah, if that's what we're going to say, then basically you're saying the theory is incomplete. Okay.
Well, that you know, that's obviously an inference that you can put in there. Yeah, that's a
Thank
way
you.
you can object. Obviously, you know, yeah, okay, that's a place where an objection can come in. As I noted when he mentioned that, I knew immediately that you were going to object to it.
Right. Well,
So
I'm not just so to speak objecting. I'm trying to understand what it is that he actually presented, and
he's saying,
it
in
could be
effect, basically,
characterized as
this
an
is a
objection
starting
or
point.
just a query as to what really is being said here.
He's essentially telling you the starting point of his theory. His theory doesn't apply to scales below 10 to the minus 14 meters.
Okay, it could be that Ian or Robert has questions, but meanwhile, a general question for Vlad, which a lot of people might have in mind, is why did you go for this, what we might call creationist view, that we have this eternal universe in your terms, and that from this eternal universe was born the present universe, which we now observe. Why did you, what attracted you to, this sort of, we have to talk about how the universe was created approach, as opposed to just trying to understand the universe as it is now.
I don't know that he's
I'm so
saying that.
sorry. I misunderstood your question at all. I don't know what you're talking about.
Well,
One universe, another universe. There are no two universes in my model. Why are you talking about two universes?
Well, in the paper that, at least the version that was distributed by email by Harry, that you wrote, you talked about the eternal universe, and then from that came the present universe, and it was born at a
There's
particular
no present
time.
universe. Where you found it? This is the paper I showed you today. What you talking about? You did
Well,
read
you
my
talk
paper.
about, you do
Talking about.
mention the word eternal universe, but I interpret that to mean something different from what James is interpreting it to mean.
I don't
Yeah,
know.
I'm not sure how to interpret it, Harry, and so
In Vladimir's model, the universe starts at it's a model, and he basically starts at a time t0, and it has a size, a certain size, and a certain time, and he starts it off at that point.
yeah, and
And
I was wondering.
he makes no he doesn't, like in the mainstream model, they basically have a problem because they have to have a transition from the Big Bang, which is at zero time and zero size. They have to make a transition from that to the macro universe that we exist in. And so then they have this transition, which is where they invoke quantum mechanics, and they have the creation of particles and this big gigantic fireball of energy. And Vladimir doesn't have that in his model. He just skips over that phase and starts at a period where classical physics applies. Does that make sense to you? I think I said that correctly.
Yeah, it makes sense, and it's basically a creationist uh, approach, a let there be light approach, and which is similar to the Big Bang approach. And I'm wondering why he apparently, I was just curious as to why he is modeling a beginning to all of this, when it seems to me that some of our knowledge is rather limited about the universe that we observe even today.
Do you have an answer to that, or do you want me to answer it?
I don't have an answer. It's just
I tell you my, I want to
what
tell
the
my
thought
comment
process
about
that
Jim.
Vlad followed. I'm asking. I'm wondering what is the thought process that Vlad followed to.
I think I'm going to give my interpretation of it, if you let me. I think what Vladimir is doing, he's dealing with real physics. He's not dealing with mathematical physics or imaginary physics or metaphysics or speculative mathematic ideological physics. And what he's saying is, I'm doing classical physics. The classical world comes into being at a certain point, and that's where my model starts. That's my assumption of it. And he doesn't get into creation, because in his model, creation is occurring continuously, but he doesn't really deal with what happens before the beginning that he postulates. Does that sound right, Vladimir?
Yes, it's right. Let me give you a comment. Jim, I'm very frustrated. You know why? I've done already over 20 presentations with Ian, with Harry, and I didn't succeed with my model against you. It means I'm doing my best. I'm trying to clarify model as much as I can. And I've done it today. Nevertheless, I didn't succeed your clarification of your questions, of your mind, of your approach, and so on and so on. Sorry, man. You are standard, maybe Orthodox, maybe somebody else who has his religion and he wants to do something according to his religion. Please be flexible. Try to understand somebody with a different view on the world. There is no present universe. There is a world we live in. There is only one universe, eternal universe. We don't know what does it mean. We don't have T0, X0, and all this stuff. There are no zero. Even fluctuation, what we have, has an extrapolated size A, extrapolated, because you can define this notion, size, only 10,000 times further in time, when it will be 10 to the minus 18 seconds, when it will be size 10 to the minus 10 meters. Only then you can introduce cosmic medium and all these parameters, space, time, and all the other parameters, what I showed you in table 1. That's why, why I didn't succeed with you, why I cannot clarify your understanding of my model. Harry told today so good words, much better, much easier for you to understand. Nevertheless, you are like a concrete, like a bed. I don't know. Why? Like a stone in your attitude to my model.
Well, this
and
is
I
not
don't pretend to. I'm sorry. I didn't finish. I don't. Sorry. I don't pretend that I've done the theory. I done model. The second point, I did do model for the whole world. Quantum, classical, no. There is no way. Let me remind you about this double slit experiment. When you're going with ensemble of particles, you have your wavelengths, you have interference pattern, and so on and so on. Whenever you started to look at each photon, immediately you have your shadow of your slits, and that's it. No wavelengths at all. Why you don't understand this simple experiment that shows the difference between classical physics and quantum physics? Why? What's wrong with you?
Well, again, you have basically admitted failure because you've resorted to ad hominem. You've characterized what my position is. My position is not against your model, not against your work, and at all. I'm just raising questions from your own presentation. And by the way, your commentary post the paper that you presented contradicts what's stated in the paper. And so where are we to, anchor ourselves in terms of reaction to what you're presenting when you're contradicting yourself? And that, I guess, I really shouldn't say anything more, because if all I get is ad hominem back, it means that you are bereft of any substantive answer to my questions.
Okay, let me ask you the question. I have my paper in front of you and myself. Which part contradict to my presentation today? Please tell me. Be solid. First of all, and your conclusion, failure of my model, you told it today. You are not blaming. No, it's a failure of this model, and that's it. Simple like this. What's your words you're talking about, guy? From one side, you told failure. From the other side, I'm not blaming your model. Can you believe it? Where you are, failure or not? And you told failure. Come on, failure for you, okay? I have no
Okay.
words to convince you.
All right.
Tell me
So we
what
sort
is
of
important. What part of my presentation and my text I have in front of you contradict each other? What part of it? Because you told many words about, but
okay.
show me
Let him answer
you
that, Amir.
experimentally show me experimentally which part is contradict to your conclusion.
Let him answer.
Well, I thought there was a time zero where the universe as we know it began.
You understood the main point. There is no time zero. There is time more than 10 to the minus 18 seconds only. At time zero, there is no time. There is a fluctuation. For this fluctuation, you don't have time, space, nothing. Before you will pass this 10 times more bigger diameter of this fluctuation, only then you can introduce notion, space, time, and all this stuff for classical physics. You see, you didn't understand even the main point of my model.
All right. Okay,
And you talk
Vladimir.
about
I
failure.
think this
What
is
kind of failure you have in your brains?
I think this is a valid point. Maybe it's unclear, and I've understood it. I'm not sure why. I don't know whether other people have understood, but I understand that your model doesn't start at t equals 0. It starts at where you define the minimum dimensions and the minimum time, and that's when it starts. And I understood that. Did anybody else not understand that?
Well, that's the first time I've heard that statement, Harry, and perhaps you're absolutely right.
That's why how I understood it. I mean, does anybody else disagree with that? My understanding is wrong.
Well, I don't know. I think maybe I'm not very far away from that, but it seemed to me that Vladimir was talking about something like 400, um, uh, about 400,000, sorry, 0.4 billion years before the Big Bang, everything started in his construction of what he calls the world. And then he talks about the universe at large
That's
being
when his model
infinite.
starts, Ian.
The model starts 14 point something thousand million years ago, Harry. Does
Right.
it? Yeah.
Billion years ago.
Yeah, thousand million years ago. Yeah. So that's where the confusion can arise, actually, Jim and Harry and others, because one has to look at that. But actually, if I may just come in quickly, Harry, because you asked a while ago for maybe comments on the clarity or otherwise, and I was going to say one thing. I hope it's helpful to Vladimir. Um, I think the conciseness of this paper, 7 pages, is very helpful, and I have actually found it helpful building on top of what he's given before. But a general question is, I'm also in agreement with the proposition that physics should be primarily experimental, and then mathematics comes in afterwards. But I consider mathematics as the handmaiden to physics. It's not to be thrown out. It's not forbidden, and it's a bit of my bias actually. When I look at a physics paper, which I'm not familiar with, I actually scan through it to see are there any mathematical equations. Now, if it's full of mathematics and no experiment, I dismiss it. But I expect to see some mathematical equations, either physical equations or statistical or curve fit equations based on the experiments that he's got. Now, Vladimir hasn't given any mathematics in this. He's given these parameters, but I'd be happier if he might have had a basis to that in a number of equations. So it seems that, if you don't mind me saying, he's gone a little too far in dismissing mathematics from his paper.
I'm very sorry. Even today, I was scared to give you all these mathematical equations because nobody knows mathematics, everybody hates it. And that's why I try to minimize the value of these equations because it's very important. This is a very important point. Once I wrote the paper named Mathematical Equations, Mathematics of my model. Once I put all the mathematics, how I calculated intergalactic plasma, how I calculated temperature of microwave background radiation, how I calculated all this stuff. I put a separate paper, and I always, when ask somebody, what about your mathematics? Please go to my mathematical one paper only, because I'm trying to clarify ideas, approach, what I am doing instead of mathematics. Even Maxwell equations, I gave very good results about the Maxwell equations. We use right now Maxwell equations for vacuum only. It's absolutely wrong. There is a special paper about the value of Maxwell equations and what should be done really with Maxwell equations and all this stuff. But I'm trying to avoid all this mathematics in my model because I'm trying to get physicists to my model. And unfortunately, even the beginning of my model, Jim didn't understand still. After 20 my presentations, he didn't understand. There is no T0, there is no, and so on and so on. The age 14.226 billion years, you can subtract this 10 to the minus 18 seconds from that, and then it will be the beginning of the story. I didn't pay attention that there is, but I take a look. Being classical model introduces classical notions only from the moment the first ensemble of particles emerge at the absolute time. I put absolute time 10 to the minus 18 seconds. And you told I didn't tell you anything about the beginning? Yes. I have a special paper, guys, cosmogony. I gave you even presentation about cosmogony. But unfortunately, I didn't succeed. Whatever I'm trying to tell you many times about the same fast radio burst, speed of light, and so on, we continue to believe in the same notions. We accepted 20 years, 50 years ago, I don't know when. Please clarify your brains, clarify your mind, and follow my logic. It's written in here, it's written, which define the value. Consequently, time, space, and gravitation cannot be discussed independently of cosmic medium. There is a cosmic medium, homogeneous and is isotropic. It's very important because all the classical physics equations we can use for the whole world. It's not a speculation, it's a confirmation that we can do it. There is absolute time, absolute space, and so on and so on. And you
So
need mathematics.
you reject the axis of evil in the anisotropy in the cosmic microwave background. You reject that because you're saying it's all isotropic.
Cosmic medium, intergalactic, cosmic medium, intergalactic, is homogeneous and isotropic. Around each body, macro object, like Earth, like Sun, like whatever, there are some extra plasma. Even around our Earth, there is extra plasma, much more concentration than intergalactic plasma. Intergalactic plasma, it has only 1 proton per 4 cubic meters. We cannot even measure this concentration. It's very difficult. We can measure it only by fast radio bursts. They've done a great job. They proved this concentration of intergalactic plasma because they're 10 billion light years ago, the 10 billion years away, some explosion raised this, fast radio burst. They are going through the intergalactic space mostly. Mostly they're going from intergalactic space with this intergalactic plasma only. And then it coming to us and we can see the dispersion of these different radio waves. It's simple, then calculate the concentration, and it's exactly what I calculated in 2013. But what is important, very important, we have some ionosphere around the Earth. We have some gala of, solar halo. We can see when we have some darkness in our world. We can see these X-rays around sun up to 8, 10 times bigger diameter than the diameter of the sun. I cannot exclude it. No, it's extra. It's a result of the behavior of macro objects itself. You have extra something. You have this intergalactic plot. Axis of evil, let me remind you, I gave an explanation on our meetings. That's why I don't know what does it mean, canceled, rejected, whatever you're telling. On the contrary, I gave a very good explanation why we have this axis of evil. Why? Because we have our plasma around sun. We have it. And it's experimental results. I put in my paper all these experimental results and show this is the cylindrical symmetry of this plasma around sun. What we're going to see about it? We want to see this intergalactic plasma. We want to see extra plasma around sun and so on and so on. And then you can calculate what is going on, interaction between our radiation and this plasma.
Okay, I think you talked about that. We got like 4 minutes left. Do you want to summarize what you've said? And got 4 minutes.
Okay, let me summarize because 4 minutes may be too much for me. You know what? More than 2 years ago, I came to Ian and asked him to give that I can give 8 presentations. It was the beginning of this story. I tried to do my best all the time, each presentation, and then a 9 presentation. Then I've done a lot of presentations there. And what is important, for me important, that even for not so many people, smart people, they develop their own ideas, their own theories, and so on and so on. And I didn't achieve my main goal, that you can accept not the theory, the model I propose. And you can, I'm asking, I was expecting that somebody, including you will tell me, oh, it's very interesting, by the way, it's a great idea. Maybe I will develop it. Maybe I will start to do something about it. I wanted to raise interest in the people around my model. In the beginning, I told you guys, there is no theory. There is no theory might be developed only by the whole physical community. And you are part of this physical community. And what's important, nobody told me, Vladimir, this idea, good. I like it very much. Let me do something about it. And then you will report, by the way, based on this model, I found this result. And what is my explanation? Look at that. It works for this model too. That's why, unfortunately, I'm in business for 24 years. For 12 years, I published papers. I published 40 papers already in my journal. I printed at least 60, 70 papers. I don't count them at all. And unfortunately, there is some interest. About 100,000 times my papers, somebody look, comment, and so on and so on. But the main guys in the cosmology, the most famous, they didn't take into account. They don't care about it. They cut this as pollution. They don't want to do any changes. They want to proceed, continue with Big Bang model, and they don't want to change their mind. And what is important?
All right, we got a minute. Yes, I understand that, and
I'm frustrated. That's it, simple like this, with physical community.
I understand that. There's a big problem developing now, which is they're at war with each other now. The quantum people are at war with the general relativity people, and there's a big war going on because they can't unify gravity and general relativity with quantum mechanics. and they're kind of casting around now for solutions. So I think that there's more opportunity developing, and it might not develop immediately. It might take some more years. Anyway, that's my final comment, and I want to thank everybody for participating today. And Vladimir, I want to thank you for taking the time to prepare a presentation for us.
Thank you so much for your attention, for your questions, for your opinion. It's very valuable for me. It's no doubts about it. But I didn't succeed, not yet in my mind, in my hope to achieve